So let's look at compound inequalities. This is lesson 1-6. And first we're going to be thinking about the question, how can we use inequalities to describe sets of numbers that have already been graphed on a number line or that maybe are in a real world context? So here we have a number line and we've got this portion here shaded with a closed circle and this portion shaded with an open circle. This is called a compound inequality because it's made up of two inequalities and it's on the same number line. So let's figure out how we can write this down in inequality form using the symbols. Well, if we look here, we see that this value is a closed circle at negative 3. So that means that, and it's going to the left, so this means less than negative 3. So this would be x is less than or equal to, because it's closed, negative 3. On this side, we have x is greater than 2. Open circle means the solution does not include the 2, but it is just greater than. Now we need to look at how we can combine this into one number sentence. So we put our x in the middle, and we're just going to read this kind of following the number line. We're going to go left here. X is less than or equal to negative 3. So because our x is on this side, we're going to flip our symbol. X is less than or equal to negative 3, and x is also greater than 2. So when x is on the left side, you keep the symbol the same because you're reading it from left to right. But when x is on the right side, when we combine the two, we need to flip it because now we're reading right to left. And that's it. So this is how you would show the compound inequality that is represented with the graph. Let's look at another one. So in this case, turn this a little bit. We've got negative 4, 0, and 1. So here we have a closed circle and it's being shaded to an open circle at positive 1. So it begins at negative 4 and it ends at 1. In this case, we can see that the two solutions are overlapping. There's a start and an end point here. This is still two inequalities. Let's look at the first one. X is greater than or equal to, closed circle, negative 4. And for this one, x is less than 1. Oh, not equal to. X is less than 1. Now let's combine them like we did in the first example. So x in the middle, we're going to start with our negative 4 here. X was greater than or equal to negative 4. So greater than, open to the x, or equal to. X is less than 1. And that is how we show that one. Now, come back over here. There's a gap, right? It was x was less than or equal to negative 3. X is greater than 2. In this case, because there's a gap here, that means that the values for x are either this or this. Okay, the solutions do not overlap. So it's an or type inequality. This one, they do overlap. So this is called an and inequality because the solutions for x are greater than negative 4 and less than 1. And it's that middle section there that overlaps. Those are the two main types of inequalities. We're going to do a couple more examples. Make sure you're getting all this down in your math notebook. And then we'll give you some practice problems. So in this case, we're going to work backwards. And we're going to have some inequalities that actually need to be solved and then graphed. So let's, remember from lesson 1.5, we were graphing. This is going to be example C. We were graphing after we solved them. So we're going to do, and in this case, it does tell us if it's an or and. So that right there should give you a visual on what your graph is going to look like. So this is 5x minus 7 is less than 13, or negative 4x plus 3 is greater than 11. So the first step we're going to do is solve. Okay? Let's solve this one. We're going to add 7 to both sides. 5x is less than 20. Last step, divide by 5. And x is less than 4. Okay? So the solutions to our inequalities are x is less than 4, or we're going to figure out the other side. So we're going to subtract 3 on both sides. Negative 4x is greater than 8. Now we're going to divide by negative 4. And if you remember, when we divide or multiply by a negative and we're solving an inequality, we need to flip the symbol around. We're going to do that both sides. So we're going to actually have x is less than negative 2. And that's the answer for that. Now let's look at it on a graph. We know that our x is going to be less than 4. 4 is positive, so it's going to go here. And the other value is x is less than negative 2. Put our 0 and our negative 2. And pay attention to precision when you're graphing on your number line. Make sure that you're not putting 0 in the middle and negative 2 at an equal distance from 0, because it's going to be closer to 0 than 4 is. So just keep to precision there when you're graphing. Okay, so now we're going to graph this first part. X is less than 4. And if you notice, we don't have an equal sign with these, so we're going to use open circles for both. Less than 4, we're going to go this way. But we need to know where to stop. Let's look at this. This is an or. X is less than negative 2. So here, it's all values less than 4, so we can go ahead and continue on this way. And then the next one is x is less than negative 2. So we're going to have another open circle here, and now these values are actually going to overlap, so we can just shade that extra on that right side. So the final graph for all points would look like this. And this is a bit tricky because you may look at this and think, oh, well, this is an and because there's 2 points and it's filled in the middle. But it's not. There's extended shading on the outside of that other point, which tells you that it's going to be an or. So pay careful attention to that. It's only when it's shaded only in between the 2 points that it's an and. Okay? So let's add to our step here. We forgot to put step 2 was to graph. Okay, nice, neat, organized notes in your math notebook. Remember, anytime you need to, if you need to pause and then continue to catch up, totally fine. You guys are working at your own pace, so that's all right. Let's do another one. We're going to keep our steps because we're using the same steps now. This is example D. So let me bring this over here. This is negative 12 less than or equal to 7x plus 9, which is less than 16. Now, if you notice, this compound inequality is already in one math sentence. So to solve this, we need to break it up into 2, okay? So negative 12 is less than or equal to 7x plus 9. So we're going to rewrite this down here. Remember, this is what they both share in common. This is like just if it was just an x value, but now it's an expression. So you're going to treat it the same way. Then you're going to have 7x plus 9 is less than 16. Okay, just like how we went from here and combined it, we're working backwards now and we're splitting it up. So let's solve this. We're going to subtract 9 on both sides. And we get negative 21 is less than or equal to 7x. We're not dividing by a negative, so we don't need to flip the symbol. And we're going to get negative 3 is less than or equal to x. Okay, over here, subtract 9 on both sides. 7x is less than, let's just do positive 7. Okay, divide. X is less than 1. Again, didn't have to divide by a negative, so we keep the symbol the same. Now, if we plug this back in, we're looking at the fact that we have negative 3. I'm just going to write this together. So negative 3 is less than or equal to x, which is less than 1. Okay, so we're going to see what kind of graph we have here. So negative 3 over here, 0 and 1. Okay, x is greater than or equal to negative 3. Closed circle, greater than, right? X is less than 1. Open circle at 1, less than. So this is an and inequality, right? These solutions are overlapping in between negative 3 and 1. So this is an and inequality. Okay, so continuing with the lesson, you guys are going to have some practice problems to work through, and then you can check your answers as you go, or actually some will be as you go and some will be at the end. And then as usual, make sure your notes are super organized, labeled. This is lesson 1-6, examples, A, B, C, D, things like that. And your try it problems or practice problems you can put underneath as you work. Have fun!